What is up, winning team? Hello, welcome or welcome back to our current book series, Beyond the Veil, Exploring the Bubble Theory and the Fourth Dimension by Ch11b. And we're delving into a beginner's journey into higher dimensions in modern physics. We are in part 2 of chapter 11, titled Quantum Connections. If you guys don't know what this is all about, listen, get to know, because this is fun. We're doing quantum, we're doing physics. I'm having a good time. I hope you are if you're watching this series. If you want to hear more what we did for the other chapters, check out the first link in the description. There's an introduction video explaining exactly why I decided to embark on this journey, and all the other videos all in a playlist that you can just watch all together if you like. Watch one a day. I don't know what you want to do. You got free will, darling. If you want to purchase the book, the link to the book is also in the description box. Get it on Amazon. Highly recommend. And finally, if you are already very much into the science, you want to know more, you want to know the details, check out the third link in the description box, which I got from the author himself, so you can delve more into the sciencey science of it all. Without further ado, let's get back into chapter 11, the second part. In the first part, we just kind of introduced the concept, or he introduced the fact that, these overlapping, is it overlapping or interlinking? Is that not kind of the same thing? But I want to be careful about using the right language here. Bear with. Overlapping. Okay, overlapping. We'll talk about the overlapping bubbles and how these could be the reasons, as in all the universes, so our universe being a bubble in a S energy field of other universes in their own bubbles, and the reasonings for why we're even looking into this is for these anomalies of things you wouldn't expect that take place in the dark matter, dark energy portion of our universe, which is seen to be 95%, but that we cannot see. So the bubble theory is suggesting that it could be that some of the things we're understanding is due to these interactions between bubbles in other universes that are in the fourth dimension. And today, in this part of the video, we are now going on to the potential evidence and observational signatures. So if you want to hear a proper explanation for what I just said from an actual physicist, go back to the part before this if you don't want to hear my butchered version. But I'm just a girl who's learning like everybody else, so I'll do my best, as you should all. So let's get into the potential evidence and observational signatures. Gravitational lensing anomalies. So we've got gravitational lensing. The bending of light around massive objects serves as indirect method of detecting dark matter. The bubble theory predicts that overlapping bubbles would create distinct lensing patterns, potentially identifiable through precise astronomical observations. Deviations from expected lensing models could indicate the presence of gravitational sources stemming from higher dimensional interactions. How interesting. Cosmic microwave background distortions. Interactions between bubbles during the early universe could leave subtle imprints on the Ch11b, which is the cosmic microwave background. These distortions might manifest as irregularities or unexpected fluctuations in the temperature and polarization of the cosmic microwave background. Advanced measurements and analyses could reveal patterns consistent with the predictions of the bubble theory, providing indirect evidence of higher dimensional interactions. So I like this part because now we're at the bit where it's like, okay, so how are we going to take all that we've done in the previous 10 chapters and all of science has done up until now into something we can quantify? That's something I got to give to the science, and why I have this obsession with partnering science with the Bible, because I feel like they're the same. It's like same text, different font, right? And I believe we should be able to study these types of things and be able to observe them tangibly, hence why I love science. High energy particle fluxes, particle accelerators, and cosmic ray detectors continuously probe the high energy environment of the universe. The bubble theory suggests that energy exchanges between overlapping bubbles could result in unusual energy distributions or exotic particles that defy standard model explanations. Identifying and analyzing these higher energy events could serve as tangible signs of higher dimensional interactions. So I told you guys, it's getting juicy. It's getting so juicy right now. So the mathematical framework simplified. Higher dimensional geometry. The interactions of overlapping bubbles are modeled using higher dimensional geometry. This is about to get so interesting. Extending beyond the familiar three spatial dimensions, concepts such as hyperspheres and hypercubes are employed to describe the shape and behavior of the bubbles within the fourth dimension. This geometric approach allows for the calculation of gravitational influences resulting from bubble overlaps, providing a mathematical foundation for the theory's explanations. S energy field equations. The S energy field is governed by extended field equations that incorporate higher dimensional parameters. These equations describe how the field propagates through the fourth dimension and interacts with multiple bubbles. I wonder if he's got some of these equations in the more work, because you guys know, those of you around here, I love me an equation. I'm an equation girly. I love equations. I love equations. I love numbers. I love diagrams. I love graphs. That's my bag. I don't like really words. I like equations. This is why I love chemistry, because in biology, a lot of times they tell you things and it's all in words. I'm like, give me the equation and I'll understand what I need to understand. Solving these equations under specific conditions predicts the gravitational and energetic effects observed in our universe, offering a quantifiable basis for the theory's claims. Fair. Energy conservation and distribution. Energy conservation principles are adapted to higher dimensional contexts within the bubble theory. Energy exchanges between bubbles adhere to these adapted laws, ensuring that the total energy remains consistent across the dimensions. Oh, this is interesting. Oh, this is so interesting. Okay, all right. The distribution of energy resulting from overlapping interactions can be quantified, providing a basis for comparing theoretical predictions with observational data. Hee hee. Sorry, I'm hee-heeing because this is what I did my own research on. My research was chemistry based, and we were predicting molecules in outer space. But then I'm just saying hee-hee because that's what I literally did. Comparing theoretical predictions, so that's what I was doing, with observational data. Love. That's like a completely different side of what we're doing here. Here we're talking about the fourth dimension. So we've moved past this dimension. Challenges and future research. Empirical validation. I love how this keeps coming up, like in a good way. One of the foremost challenges of the bubble theory is empirical validation. Detecting indirect evidence of overlapping bubbles requires advanced observational techniques and precise data analysis. Future research must focus on refining these methods to identify the subtle signatures predicted by the theory, such as specific patterns in gravitational lensing or Ch11b distortions. I see. Okay. And it's actually, I feel like it's the subtle signatures that's the difficult part, because as I know from doing my own research, obviously it's hard to get really clear, refined results for things that you can't see. You don't know, you're not even 100% sure what kind of equipment, what other things, you're not sure what you don't know. So getting really strong, refined data, I can also identify, as it says, subtle signatures, is difficult to do. Theoretical refinement. The mathematical models underpinning the bubble theory need further development to provide detailed predictions and align with existing physical laws. Integrating quantum mechanics with higher dimensional field theories remains a significant hurdle that requires collaborative efforts across multiple disciplines. Enhancing the precision and predictive power of these models will facilitate their integration with established frameworks in physics. So the technological advancements, and I'm making that face, by the way, because I did joke in one of the videos about how, don't leave us chemists out of the equation. No pun intended there. But it's true. A lot of this requires you need a team. You guys know, we call this the winning team. And one of the things, this is just a great time to talk about why this channel is the winning team as well with the science. I believe that a lot of things are a group project, and in a good group project, right, you need different people with different skills and expertise to come together and put their brain power there, what they understand, in order to move forward. Science isn't a one-man job. It's not a one-man band, because there's just not enough time in the world, right? So even though I might be saying I wish I'd known more about physics, but would I have had the time whilst I was, studying chemistry all this time? So, and this is what I love about the team aspect. Welcome to the winning team. If it's the first time, this is why we're called the winning team, because we love everybody, because we believe everybody is valuable and everybody has something to bring to the table. You see what I'm saying? And when we work together, great things are possible. That's just a side note. Technological advancements. Advancements in telescope technology, particle detectors, and computational modeling are essential for testing the bubble theory's predictions. Can I just say another thing I'd like to critique the science community for? I do feel like there's not enough opportunity for the cross breeding, if you will, across disciplines. I feel like it gets so, and I blame the education system, not people, for this. I don't know how it's like all over the world, but me, who's done my degree in the United Kingdom, I'm accredited by the Royal Society of Chemistry over here. I don't know why there's not more of an effort to partner with these types of projects. Because, like, say if I'm studying somewhere and I'm doing a pure chemistry degree, or I'm doing a pure chemistry PhD, or whatever I'm doing, I don't see why there isn't an option that while I'm doing my research for my own research paper, why there's not an option to collaborate with, say, or the physics students as well. And also for potentially the mathematics students. I don't see why we don't do that in education. Honestly, now that thought's just come through my mind, it's just opened a whole floodgate worth of thoughts about the education system. But nevertheless, because I think we would gain so much more, even if we were to learn some of these concepts more together. I know in a lot of degree courses they do, but I feel like some of these concepts, if we were learning together with our different disciplines, even at the same time, probably the way we would look at these things is very different from each other as well. Because I noticed that even just from studying myself, we all went off different pathways in doing the subjects that we were doing. But there was an overlap, obviously, of the subject, but we all kind of shined in different areas. And again, going back to what I said about team and the importance of, as he's put it, interdisciplinary collaborations. So let's go on anyways. Technological advancements in telescope technology. Again, why have we got rid of telescopes? It's another failing, I feel, of society. We have TVs now. Back in the days, people used to look at telescopes. My children will most definitely be having telescopes. Just like to say that. Particle detectors and computational modeling are essential for testing the bubble theory predictions. Investing in next generation instruments will enhance our ability to observe gravitational lensing anomalies, Ch11b distortions, and high energy particle fluxes with greater precision, thereby providing the necessary tools for empirical validation. And also, just to add as well, as we've been talking about this, I can't believe this again, but anyway, you'll see what I'm saying in a second. This stuff costs money. Like when I was doing my own research, bearing in mind, I was not some kind of like high level scientist, right? This is my first ever research paper doing myself, whatever, you know what I mean? As a new scientist, that's when I learned how much this stuff costs. And like I always say, sometimes people really trust in science a bit too much, because the things we know and the things we don't know are also largely based on who decided to pick up what and who decided to research what and do what. So if nobody has paid for certain research, paid for certain equipment, like I was doing computational modeling and calculations for my research, right? But I was limited by the fact that there wasn't funding to be able to do the higher level calculations, because of course it's expensive to have these computers that can handle these kinds of calculations. The softwares are expensive. Obviously the scientists who come up with / mathematicians who come up with these calculations, they also, deserve the rights to the fact that they made their breakthrough. So making sure that those people are paid properly as well, because you're obviously using theories that other people have developed, because like I said, we're passing on the baton as we go. So there's a lot of things to think about there in terms of costing. That cost is a huge limitation. And that's why things that are being done are only being done because somebody's paying for it. That's one thing I always say to people when they're like, where's the evidence? Where's the scientific research? Well, you may not have the science. This is why I'm genuinely praying to the Lord to have my own research lab one day. Sometimes you don't have the research for something just because whoever is studying it or whoever's involved hasn't got the funding or the resources to be able to do such. Because even if you were to embark on a journey like this, which goes swiftly on to the next title, which is interdisciplinary collaboration, you would need to also pull in experts in the individual areas. Because as I said, I've said to people before, people have a misconception that when people do like a PhD, like if I have a PhD in chemistry, then I'm like a chemistry expert. No, the chances are I've picked one particular area of chemistry that I know a lot about in one particular area. and one particular hypothesis or theory usually that I know really well. So even in the disciplinary itself, we also need to have strong collaboration in order for these theories to go forward. So I just thought I'd mention that as well, because it's something that I think people don't think enough about. And then he goes on here to interdisciplinary collaboration, addressing the complexities of the bubble theory necessitates collaboration between physicists, mathematicians, astronomers, computer scientists, and chemists. Thank you very much. I'm saying that because I was joking with him about this. Interdisciplinary research initiatives can foster innovative approaches to solving the theory's multifaceted challenges and accelerate progress toward validation. I can agree with this, by the way, because there's so much for what people don't understand. As somebody who really is obsessed as a chemist with things like atoms and the concept of atoms, and like he was talking about even in here, the elemental particles, things like that. People really do underestimate how deep a lot of this stuff goes in terms of our over understanding of everything. So the conclusion is that the bubble theory offers a groundbreaking perspective on dark matter and dark energy, proposing that these elusive components of the universe arise from overlapping bubbles within the fourth spatial dimension. By providing geometric and dynamic explanations rooted in higher dimensional interactions, the theory unifies previously disparate phenomena under a single framework. I don't know if I've said that right. While significant challenges remain in empirical validation and theoretical refinement, the bubble theory stands as a promising avenue for advancing our understanding of the cosmos. Continued research, technological innovation, and interdisciplinary collaboration will be pivotal in uncovering the truths that lie beyond the visible veil. Beyond the visible veil. I like that. So we're adding even layers to the title because it's beyond the veil. Beyond the visible veil. That's interesting. So next we're going to go on to philosophical reflections. It's going to be the next chapter. So that's going to be interesting when we get to that. I can't believe we've got 3 chapters left. But there you go, you guys. That's where we're at as far as this concept. So yeah, this is insane. This is really interesting. I highly recommend looking at this for yourself. Like I said, once we finish the whole book, we're going to have to go back through a lot of theories. I'm keeping in a lot of my thoughts until I've read the whole thing. But a lot to think about here, lots of food for thought, both in a scientific sense in terms of the fourth dimension and what it could mean for our understanding of the way our world and our reality actually works, all the way down to just good old life tips like interdisciplinary collaboration. Hello, when you work as a team on something and shared people with different strengths and weaknesses, with different areas of expertise, the possibilities are endless. The need for the sake of collaboration always. Science is not a one-man band. It's not a one-man job. And also the difficulties in science itself, I think, of, these things actually happening. Like for us to be here, he had to sit and write this book. Or I may never have come across this. I may never have known about this. So again, it takes people actually going out of their way to study these things, to put their attention, even if it challenges what we've previously believed. Just like how the people that were the first to start talking about things like the expansion of the universe, is it even static, would have looked crazy. And this is why I don't mind sharing my personal thoughts, because this is what it is to be a scientist. To be a scientist, you got to be prepared to question the things that other people feel really sure about, and not because you think you're better or you want them to be wrong. But as I learned doing my studying, it helps you to be a critical thinker, which of course is not taught in schools anymore. They want you to not think critically. They want you to get in line and follow the rules without questioning. But it's how I learned. It's how I got good in science, because you get critiqued. Like, try presenting a research paper to people who are way more qualified than you, and you understand what it's like to be criticized, because you'll have them being like, so you referenced this reference here from 2017. Have you not checked to see if there's a more recent paper? Have they not come forward with what they're doing now? Did you consider the concept that this? It sounds insane, and it is brutal in the moment, but it's amazing, because this is how we do better. This is how we learn more. Because if life's a game, let's play to win. If you guys want to watch the rest of the series, like I said, playlist is linked in the description box down below. Catch up if you haven't caught up, do your homework. Check out the intro if you're still confused while we're doing this. Grab the book in the second link in the description. And if you want to delve deeper, hit that third like in the description box to get even more details about this theory. Other than that, I'll see you guys in chapter 12, which is, what is it? Or maybe I'll just make you guys wait. so that you come back. If life's a game, it's pay to win. God bless you all. God loves you. I love you. And I'll see you in my next one.